Okay, so we shall get started. So hopefully you are here to hear about OpenTelemetry. I am not talking about .NET. I know some of you know I talk about .NET a lot. I am talking about JavaScript and Typescript because other languages exist, apparently. So we're going to talk about OpenTelemetry. We're going to talk about how we can use it. And we're going to talk more specifically about practical use cases. So what do you actually do to put it in rather than just going, here's a few service defaults, throw those in, everything will happen. But what should you be doing and how should you be doing that? That's the focus of this talk. We're going to be using mostly TypeScript, but obviously a lot of this works in JavaScript as well. So my name is Martin Thwaites. I am first and foremost an observability evangelist. That means I talk about how we observe our production systems, how we understand what's going on in production systems. I've been talking about this for about 10 years now, which makes me sad when I think about how long that's been. You can follow me on Twitter, on Mastodon. I've recently started a YouTube channel where I'm doing some short videos on this kind of stuff. So feel free to subscribe, follow, all that jazz. Do be aware, I do have a lot of British snark in everything that I do, whether it's this talk or on Twitter, so no refunds. We can't talk about OpenTelemetry without talking about observability. Because observability is the why. OpenTelemetry is the how. And if we don't understand the why, how can we understand what to do with the how? So this is a quote from Charity Majors, who runs the company I work for, Honeycomb. Just to be clear, I'm not here to talk about Honeycomb. We're talking specifically about OpenTelemetry, which is vendor agnostic and completely open source. The quote around observability kind of started around 2017, 2018, when at that time we were thinking a lot more about metrics and logs and really about that analysis flow being, let's look at some graphs, let's maybe go and have a look at some log lines. Hopefully we'll be able to get some information. And what happened was Charity came out of Facebook and started to think about the tools that they had there and how they were different to what we had in the industry today, as in today being 2017. So thinking about the idea of something called Scuba, which was an internal system that allowed them to look at really what was happening on the inside of every one of their systems. But there wasn't a word for it. There was log management, there was log analytics, there was metrics analysis, there was graphs. But there wasn't a word for something that meant more than that. And that's where she fell on observability, which comes from control theory. It's not new, it's from the 1960s. But it's how we understand the inner system state of our system from what it tells us from the outside. Now you'll notice there I've not mentioned pillars. I've not mentioned logs, metrics, and traces in that definition. Neither has she. Because that's not what observability is about. Observability is about how do we understand what's going on the inside just from what it gives us on the outside. And what it gives us is telemetry data. Now, the thing I want to drill in on is this bit here. It's about the inner system state. It's about understanding what's happening on the inside. It's not about what's happening on the outside. It's not about the request volume. It's about what's happening on the inside and really understanding deeply what's going on. So why does it matter? Well, I've had that slide in my deck for quite a while now, and nobody has disagreed with it. Because, yes, we are. When I started development, we had 6-month development cycles. You deploy on every 6 months. It was June and November. That was don't do it in December. No, we do it in November, and we'll do it in June. And you'd be working for 3 months. Then you'd ship it over to the QA team. The QA team would look at it and come up with a load of bugs. Then it'd come back to you for a month, and then you fix all the bugs. And then go back to them, and then go, yeah, we can release it. And then it'd be passed over to the DevOps team and the operations team, and they'd build runbooks, and then they'd go and deploy it. So what you were writing was being shipped out 6 months after you wrote it. And you didn't support it. You weren't close to this application at all. It was somebody else's job. But nowadays, we're being asked to ship more often. Whether it's every 2 weeks, every week, every day, per commit deployments. we're being asked to ship more often. And while we're being asked to ship more often, we're being asked to produce better code. Like, can you make the code that you ship every day, can it be better than the code that you were shipping when you had 6 months to deliver it? Yes, please. Okay. And also, while you're doing that, can we spend less time fixing bugs and more time like creating value and features? So yeah, ship every day, better code, less bugs. Awesome. And while you're doing that, can we not have any downtime? Now, if we're asking people to do that, but we don't change the way that we think about our tools, how we think about how we observe, how we understand what's going on, why weren't we doing this 6 years ago, 10 years ago, 20 years ago, when we had logs and we had metrics? We've had Elasticsearch Elk Stack since 2012. We've had log management, we've had log analytics, and we've had metrics for the last 12 years. Why weren't we doing all the things that we're being asked to do now, and we're being asked to do differently? Well, yeah. The problem is that all of those things lead to a level of fear. Now, I do need to point out, apparently there are people who don't know what one of those is. That's called a server rack. It has servers in it, and that's where your code runs. There's lots of them in the cloud. It made me sad when somebody asked me what it was that was on fire. But ultimately, what all of those things, because we're shipping more often, we're being asked to produce better code, we're being asked to look at a system that is 3,500 microservices, it leads to this idea that we don't want to ship things because it's so hard to understand what's going on in the production environment. It works fine on my machine, but when I go and put it over there, that's hard. What we really want to get to is the idea that the production system is just a different part of your team. Because in order for you to deliver value to customers, in order for you to give them the code and the features that they want, you can't do that without production. Production is just another facet of your team, and that's where we want to get to. We want production to be a safe place. We want it to just be an extension of what you're doing. And that is where OpenTelemetry comes in. So what is OpenTelemetry? Now, OpenTelemetry was born around 2017. It's not new. Around 2017, there were two other competing projects, one called OpenCensus and one called OpenTracing, which were all around the idea of distributed tracing initially. Now, there were two competing standards at this point, and you had all of these disparate systems. Some of them were like, yeah, we're using OpenCensus, and we're using B3 propagation to go to our Jaeger backend. And then somebody else is saying, well, we're using open tracing and we're using W3C tracing context, and we're sending all of our stuff to our Zipkin backend. It's like, great, okay, now we can't interrupt. So they understood this, and obviously as engineers, the first thing that we do when we've got two competing standards, we create a third standard. And now what we've got is three competing standards. However, OpenTelemetry is the exception because in 2022, OpenTracing and OpenCensus went deprecated. They deprecated themselves in favor of OpenTelemetry. We built all the shims, all the bridges that allow those people that were in those ecosystems to come and use OpenTelemetry. So OpenTelemetry is now the one true way. It is the de facto standard for doing these things. It is the #1 project coming out of the CNCF now. Apparently overtook some container solution. Apparently it was really popular. Kube or something, I don't know. But it's the #1 project. It's become the de facto standard. So we're at a point now where nobody gets fired for suggesting they re-instrument with OpenTelemetry. It's the IBM of the telemetry world now. But what is it? Now, first and foremost, OpenTelemetry is about a protocol. Specifically, it's about the protocol of how we get data from our system into a backend system to analyze it. So how do we get our telemetry data that we've generated in our application and forward that to a backend system so that we can provide some analysis, some charts, metrics, if you like. That is the most important thing about OpenTelemetry. It's the reason why all of the vendors have got behind it, because it means now that only one particular team, particular protocol needs to be supported on your backend. You don't need to think about SDKs. It's the reason why in the last 2 years, we've had a record number of observability companies pop up out of nowhere and say, we do observability now. And it's because, well, OpenTelemetry allows them to not care about what's instrumented in your application. Because not only do they provide the protocol, they also provide the SDKs. They provide SDKs for 11 different languages. JavaScript is one of them. And those SDKs produce the data in the OpenTelemetry protocol format, the data model of how it goes to the back end. Now, we've defined various signals, not pillars, signals. Because there are no pillars in OpenTelemetry, there are no pillars in observability. There are only signals. Now, there are 5 signals that you should be aware of and care about. Logs, metrics, and traces, probably the ones that you've heard of. They're all stable now in the standard. So all available to use in all 11 languages. There is another one called profiles, which is low-level continuous profiling data that goes down to syscall and kernel level stuff. That is at the point where the protocol is stable, so how we transfer that data from an application into a backend to analyze it. That bit is stable, but the SDKs are not. You can do things with things like Pyroscope and the new Elasticsearch profiler that's just been donated to the CNCF. There is some work in there, but by no means is that stable and something that you can rely on right now. Something you can use, something cool. What I would say is the majority of the time, if you're looking for performance analysis and you're hitting a database, if you're profiling, you're doing it wrong. Because as soon as you hit a database, you've probably got 4 or 5 millisecond latency anyway. Saving a few nanoseconds by doing some low-level profiling is not going to help you. But it is cool. The other one is RUM. It's the bad kind of RUM, not the good kind of RUM. We'll have the good kind of RUM all later. This is called real user monitoring or client side. It's the ability to see what's happening on the client side. Now, at the moment, that is in the design phase. Because the thing with things like OpenTelemetry is we have committees. And committees have people, lots of people. Lots of people means lots of ideas. Lots of ideas means nothing gets done. So we're in the design phase. There's lots of ideas about how we model the data, how we model a session, how we model a page view. All of that is in flux at the moment, which is why we're going to be focused on backend. A lot of the stuff that we're doing around traces and metrics and logs in this talking about today, you can use in the web front end. All of the distros are experimental for the front end at the moment, but they do work. So let's talk about the signals. Tracing. Probably one of the most misunderstood signals because people believe it is what it's not. They believe it's useful for different purposes. Really, it's about debugging. Tracing is about debugging a system. A system might be distributed or it might not. Tracing is useful in systems that are monolithic as well as it is in distributed systems. It's kind of mandatory for distributed systems, but it's not in monolithic systems. It's still really useful though. But it allows you to be able to visualize a complex system, give you an overview of what's happening, how something transitions through different components of your system, whether that's different classes if you've instrumented those, or whether it's individual microservices if you're running in a distributed system. But it has a focus on something called causality. A focus on this thing happened after this thing happened because of this thing that happened, which allows us to build these really funky tree views and see where all our performance gains can be achieved. Because it does have a focus on performance. Because every trace will be able to show you the time taken in each one of those actions. It's a core part of tracing. Now, the other thing about tracing data is it has a focus on high cardinality and high dimensionality data. High dimensionality data is the amount of individual attributes you have on each one of your entities, so spans in the tracing context. But the cardinality means for each one of those attributes, how many possible values are there for that? High cardinality data is IP addresses, user IDs. Low cardinality data would be success response, fail response. Because there's 2 possible values or millions of possible values. With the tracing data, we focus on high cardinality data and high dimensionality data. So what is a span then? Because we don't create a trace. What we create is spans. And every span that we create has some unique properties. And those properties, one of them is a trace ID. And that's how we build a trace. But it's essentially just a structured blob of data with some mandatory characteristics. So it has an ID that associates it for itself. We call that a span ID. It has a correlation ID, so something that will correlate all of these spans together and make a trace. We call that a trace ID. Correlation is something that I would imagine most people would understand. We've been doing that for years. It has a start time and an end time. So yes, you can add those to logs, but these are mandatory in tracing. But the thing that sets it apart mostly is causality, the parent ID, the span that came before it, because that allows us to model these funky trace views that you can see, I'm assuming on the left, on the right, that way. Now, the other thing that it has on there is a bag of attributes, arbitrary attributes. Some of them come from what we call the semantic conventions, so things that OpenTelemetry have defined as names. But you add your own. You can add as many as you want. There are limits that you can change. Default is about 128. And then the limit then comes from your vendors or your backends. But it's just a structured blob of data, much like a log, but more fancy. Oh, the other way to put that is logs are just boring traces, really. So what is a log then? Well, a log is a point-in-time bit of data. So we have a timestamp that says it happened at this time, and it has a message template. And the reason it has a message template is because they're designed for humans to read. We can try and make them structured by using something like if you're in .NET world, a Serialog parser. There's a few for JavaScript, because it's JavaScript, and there's like 14,000 things that do the same thing. But ultimately, it is made for humans. So we add a string template in there, and we do some string interpolation to add those things in there. Now, they're really good for local development use cases because they're immediate, and we see them right away. They're great for startup and crash data, but they're also really good at debugging whether your tracing is working or not. I mean, they're fine, I suppose. The thing that we don't like about logs is they lack the context that a trace does. That's the main differentiator. Logs are great. If you do logs in a very, very structured way, where you think about consistent naming of all of the different attributes that you add to those logs, if you think about something called canonical logs, where you have one log per service with tons of context on it, logs are great. But generally, they end up as unintentional observability, because you've added them for your local development, and then they end up in production, and we're trying to make sense of them. Fun story, at Honeycomb, we did an analysis of one of our customers' logging volume because they thought they were paying quite a lot. And we worked out that 10% of their logging volume had a message template that said, here. 10%. Here. That was not useful. That's not counting the other ones that were here too, here again, also here. They're unintentional. We don't write them as if they're production observability. We write them for local and then try and translate them. By contrast, traces are the opposite. You generally write them from a production use case and then find use from them locally. So how do we set them up? Before I do that, I want to talk a little bit about the state of web instrumentation, because we're going to talk about how we use this in Node. But you can use a lot of these concepts in a web context as well. Now, at the moment, it's all experimental. There is an experimental web library that OpenTelemetry have produced. It's currently quite large, which is one of the big problems with it. But it does do all of the signals. So, yes, you can use it. Should you use it? I'll let you choose. We call this client-side instrumentation because the model that we're working towards can be modeled in mobile, on IoT devices, but ultimately it's client-side. It exists on the client, which means we have problems around things like ingest workflows. Because when you're on the back end, you can send all the telemetry to your back end fairly easily on private network. When we talk about the front end, we need to come up with standards about how we filter that data, stop abuse, telemetry poisoning are terms that are particularly a problem in that kind of space. So there has been some progress by some companies. You may have heard of Grafana Faro, which is a kind of influenced by OpenTelemetry version. It's not really OpenTelemetry. We've created one as well that we use, which we have a backend that we use for it. They're all available. There's a few more that have gone out there, but ultimately there's no standard yet. So when we talk about OpenTelemetry and web instrumentation, it's not there. But there are certain vendors that are doing some stuff. Okay, so when we put this into our code, there are a few different ways that we can do it. So we can use something called auto-instrumentation, which we're toying with the word now of zero-code instrumentation, because ultimately it means that in your code you don't have to do anything. So Codeless, generally it is side-loaded. We use environment variables to configure it. It's incredibly good for getting started to see whether this is something that you're going to get value out of. But it is very verbose. There's a lot of data that comes out of it. Generally, a lot of it isn't very useful, but there's a ton of value in the rest of it. It's really easy to do. Literally add a few environment variables and then run your app. It's not particularly difficult. But ultimately what that is doing is it's going to send all the signals, all three signals, to that endpoint. It's going to give it a name, and you don't need to do anything in your code. And you'll get the default instrumentation, things like node, not node fetch, but node. Sorry, not fetch, not node fetch. A lot of the things will just happen out of the box. It's really good when you're in a situation where you've got multiple teams, multiple microservices, and you want to instrument your code with coded instrumentation, doing it essentially properly, but the rest of the teams don't. You can use this to just drop it in, and it will just work. They don't need to do anything. So you can get a large distributed trace across your entire system without having to get them to do any work. Pro tip, though, don't just go into their code base and just add it. They don't like that. Ask me how I know. So the real way we do it is about coded instrumentation. Now, coded instrumentation, you essentially just add some stuff at startup. It's not that hard. Depending on the language, it can be 20, 50 lines of code in a file. In some of them, it's as low as 10. But essentially, what you end up with is targeted instrumentation, where you choose which things you want to instrument. Do you want to be able to see SQL data? Do you want to be able to see Mongo data? Do you want to be able to see how it accesses third-party services? You get to choose. You get full control of everything that's happening in that telemetry pipeline, which ends up being that you are intentionally instrumenting your code. You're thinking about that instrumentation. If we go back to what observability is, being able to ask those questions, being able to understand that inner system state, being intentional about what is important in your code base is what observability is all about. So how do we add the signals? So logging, metrics and traces, fairly easy. A couple of packages from OpenTelemetry that you install. We add some exporters. Exporters are where we tell it to go somewhere. These ones are using the console exporter. So this will just write stuff out to your console. Don't use this in production. This is really good for getting started, the debugging journey, to work out whether things are actually generating some things. If you're worried about setting up a telemetry pipeline and a backend and whether there's communication happening, use the console exporters to see whether it's generating telemetry at all first. Then switch them out into a OTLP exporter, which is where that sends it to a backend over gRPC or HTTP. Now, the other thing we do there is we've got get node auto-instrumentations. I've typed that wrong so many times, that's why I wanted to check. But ultimately, that's going to grab a load of standards, instrumentations, like it'll do something called node fetch, it'll do the Postgres, but it won't do things like AWS. It won't do things like, unfortunately, node fetch, which uses something called NDC, which is a name I don't understand and nobody's ever heard of, apparently. All the JavaScript developers I talk to, they don't know what that is. But apparently that's the thing under the hood that node fetch uses, and the native fetch stuff. It's pretty simple. This is all in the docs. There's no need to take any pictures. Go and have a look at the docs. It's not hard, though. For logging, you can hook into some of the logging providers. Bunyan, pretty popular one. You can hook into that and use that to output anything that you use as with the Bunyan logger to send it over. Now, we talk about logging, though. We're not talking about logging as in console logging. That's not what we're talking about here. We're talking about log lines. Now, you might have heard of 12-factor apps. Pretty popular. It was something that Heroku came up with in, I think, 2010. Which was the idea of portability of applications between different services. Really nice concepts. They had a concept called logs. And what they were talking about with logs was you should pipe everything to standard out. Now, the sentiment behind that was that your application shouldn't know where your telemetry is going. It shouldn't know what format to use. It should just push JSON files or strings out to the console. Now, that's superseded in a way by OpenTelemetry because OpenTelemetry is now the standard. All you really need to do is be able to control where it's sending it via a URL. You can configure it from the outside. So an SRE team or an ops team can quite easily say, we're going to send it somewhere else versus where you're going. So, yes, it does go against 12-factor apps by the definition. Whether they end up changing 12-factor apps, I don't know. I do know that the Kubernetes community are all on board with this now. So very much the Kubernetes community will be moving towards the standard out and log rotate and all of that being the standards. That will all be going over the next few years. Now, the get node auto-instrumentation stuff will add a load of defaults, but there are extra ones that you can add because ultimately you want to be able to curate this. You want to be able to tell it which ones you want. So the instrumentation libraries are language and SDK specific. So different SDKs will produce their own OpenTelemetry libraries, their own OpenTelemetry instrumentation libraries that you can add into that instrumentation section. So stuff like Postgres, Fetch or Node Fetch, the Fastify stuff, the Express, they've all got their own instrumentation library packages. So you don't have to be going in and creating a span every time you get a request into your Node Express API. You don't have to make a span every time you call a third party. Those things will just happen. Again, this is really good as a step one of getting started because we get all of those spans for free, and they're really useful. We do want to go a bit further, and we'll get onto that. So if you are using Node Fetch, that is the line that you want. If you are not getting any spans for your external stuff and you think you've just added to get node auto-instrumentation, that extra line on the bottom there is the one that you want. It took me a long time to realize that, and there's not a huge amount of docs on it. But yeah, that's the line you want, NDC, whatever that is. If you're using the get auto-instrumentations package, Node.fs, the file system stuff, is incredibly chatty. It produces tons of spans. Just disable it. Talking about practical things that you can do, just disable the file system instrumentation. Most people won't need it because you care more about what the user sees. And if it's a static file that you're seeing, you're going to see that the static file took a long time, and that's the thing that's going to happen. So Do disable that one. 99% of all of our customers and everybody else I speak to has added that line to their code. Why it isn't the default is beyond me, but hey-ho. Now, the other thing is Express can get very chatty. This is an example of a trace from Express, and you can see that we've got an extra 4 spans that are connected to nothing that are incredibly fast. They're never going to be slow. Maybe if you've got a large JSON object, the JSON parser might be a bit slow. Ultimately, they're not really that useful in the majority of contexts. You can turn them all off. So you can turn off the request handlers, you can turn off the routing, just by adding these things. And this is a pattern that you'll see all over the place inside the get node instrumentations. Add the package name and add some properties to it like that. And it will stop it from generating the spans in the first place. You don't then have to try and postfix. Okay, so that's all the basic setup of how we add some instrumentation libraries, how we get some basic data out of it. The next step is making it useful to our context. Because if we don't, we're stuck in the APM world, the old school world, where we'd add an agent to a machine and they'd do all of their telemetry to make it look fancy and give you some nice pretty dashboards you can put up in the office so the bosses think you're doing stuff. But we really want to make this useful. We want to make it specific to our context because there's a reason why we're developing the software and not just buying it off the shelf, because we've got some uniqueness in our product. So we use something called resource attributes. They're the most useful attributes that you can add. And the reason is because they're added once per process. They don't change. They're sent over to your backend once in every batch that comes over. It goes, these resource attributes for all of your things. They're meant to identify something specific about the process, the resource that is generating this telemetry, to allow you to do correlations between this and maybe some metric data, to look at some infrastructure metrics, to look at some logging data. That's why they're useful. So we add specific attributes. This one is using 2 specific attributes from the semantic conventions. We'll talk about the semantic conventions later. But they apply to all 3 signals, spans, metrics, and to our log records as well. But they're useful for things like your pod name in Kubernetes, the region that you're running in AWS, your availability zone in AWS, maybe the version of the operating system it was running on. Maybe that's important. But you should add as many of these properties as you can to that telemetry data. And they're added inside the Node SDK when you do it. Now, one thing I didn't mention, forgot to mention this, the Node SDK is marked as experimental, where it says Node SDK on that screenshot there. It is marked as experimental, but it is the thing that everybody uses. It is stable enough for everybody. Don't go to the old school methods. Use the Node SDK. It's what everybody's using. It's what all the cool kids are using anyway. Or so I hear. I'm not in that crowd. So, metrics. I love metrics. Metrics, we use something called a meter. Meters are created pretty simply like that. Now, a meter doesn't really do anything on its own. It's a group of what we call instruments. So then we configure the meter by adding instruments to it. Now, my recommendation is to generate your own class, pass in the meter, and then add all of those individual instruments as properties on that class. That provides a nice little abstraction away from being able to just create loads of things and dirty up all of your code. You can pass this object around a little bit easier. And then to record our metrics, what I generally recommend is to add yourself some abstractions. Don't try and interact directly with each of these individual instruments. Add a thing, add some metrics like, these ones here. So when we've got a sale of a product, we've got a purchase product object, throw it into your metrics instance and just say, record my sales metrics. And let that do all of the things it needs to do instead of adding those to every line of code that you've got. Now, the other thing is it allows you some readability in your code because you know that what you're doing is you're adding some sales metrics. You don't care what those sales metrics are when you're reading your code. which means that your code is a lot more readable. So it's pretty self-explanatory, I think anyway, but adding some class and adding a wrapper class is pretty useful. And then the way that you use those metrics, you can pass that metrics class around and just do add sales metrics. And when you've got those auto-instrumentations in place, you've got all those exporters, it will just export all of those things to your backend. You don't need to do anything else. The thing to know about with metrics is they're aggregations. So when you add this in, you're going to have to wait between 10 and 20 seconds to see that on your console or to see that in your backend. That's normal. Because what a metric does is every time you increment these things, it waits 10 seconds, aggregates all these things up, then passes them to your exporter in OpenTelemetry. The exporter then batches up these things over another 10 seconds and then sends them to your backend. So you're not going to get these things immediately. It's not generally a problem. Just know that it's when you put them in and you don't see anything in the console and you think it hasn't worked, it has. So tracing instrumentation. Pretty similar. We get a tracer in the same way. The tracer is what allows us to do all of these things. We can start a new span. In this particular example is not what I would recommend because we're already going to get a span for our instrumentation from Express. So we don't really need to add an extra thing. But that's as simple as it is. So let's go a little bit further then. So we're going to talk a lot more about tracing than we are about the other signals. I'm not going to talk about logging because everybody knows how to do logging. I've showed you how you were able to use the OpenTelemetry SDKs to extract that logging and send it to a backend. That's as much as you need to know about the logging side. There's lots of good talks about how to do good logging. Metrics side, it's as simple as I've just told you. The only thing I would say is from the metrics instrumentation on here, you'll notice that I've not passed over a ton of attributes. I would say product ID is a medium cardinality attribute. But I've not passed over user ID. I've kept the attributes quite fewer. And I've not added a load of high cardinality attributes. That's specific to how you do metrics. Keep them low. Don't pass over an IP address. Your platform engineering team will kill you. They're not happy about it. Prometheus doesn't like it. Neither does Influx. But that's not a slight on those tools. It's just the way that time series aggregates work. Tracing instrumentation. Some of these are now getting into what I consider best practices about how you should instrument your code to make it more readable and have the best chance of you being able to understand things. Now, the difference between those two bottom screenshots there is one of them, we're adding an attribute that has the entire object serialized as JSON. Don't do that. What you should do is think about the attributes on that object that you want to add as attributes. Am I way behind? No, I'm good. Okay. So, add the specific attributes that make sense, the things that you think are important. Don't add PII data like first name and surname. Just because it's on my slide doesn't mean you should do it. But extract those individual attributes that you think are important, give them names. Don't expect to be able to pass over an object and just let the backend sort it. But the biggest problem with doing stuff like that is as soon as somebody adds something to that object, like, okay, we've got a person. Well, people have got credit cards, right? So let's add the credit cards to that person, then we'll just log the person out. Okay, now our backend system, our observability system is now in scope of PCI because now I've got all of my credit card details in there. Don't do that. Also, don't store credit card details in general, but that's a completely other talk. But be intentional. Think about what's important, add those things explicitly, give them explicit names. But also think about adding classes that wrap that data in specific context. So in this one, I've got a span enrichment class, where what I'm doing is I'm adding a method that says enrich with person. So I pass in my span, and I enrich it with the person object. The reason why this is really interesting is because now anybody who wants to say, I've got a span, and I'd like the person details to be on that span, are going to get all of the same attributes with all of the same names. They're all going to go in the same place. Which means that when you're trying to query these, when you're trying to build analytics off the back of your spans, which is what you should be doing, you're going to have some standards. Now you see at the bottom there we use getActiveSpan. That gets the current span that's active in our application so that we can enrich it with extra data. We don't have to create a new span in order to do this. When we do create a new span, now this is how I believe all retailers do markup of their prices, just random numbers. This isn't how I would write code, by the way, just in case there's any potential future employees out there. But ultimately, the reason why we would create an additional span around this code is because that middle section of that code is going to change its performance based on the input data. Because the category ID, as it gets bigger, we're going to do more iterations of that loop, and therefore it is going to be slower each time. So that is something that we would want to monitor. So we add a span around it. Now there is a new SDK coming for JavaScript, well, more specifically a TypeScript SDK that is a TypeScript SDK, which will implement things like disposable patterns and things like that, which will make this code a little bit tidier. But for now, yes, you have to provide in a delegate on the function at the bottom to provide that. And that's going to create a new span. It's going to have some attributes that we've created at the top there for the price and the category ID. We're going to do some things on that. We're going to run our function. And then we're going to set an additional attribute at the bottom. And then we're going to stop that span. And then that will get pushed to the back end. Now, personally, I hate magic strings all over my code base. Too easy to get wrong. Two places might use different strings. How many times have we seen in our backends, oh yes, that was in pre-production. Oh, you mean staging? Oh, you mean p-prod? Give things standard names. Use a constants file. Grab yourself a big constants file with all of the different attributes. Put it in a class if you want to, or just declare constants like that. Doesn't really matter. Whatever makes sense to you, throw that into a file, throw JSDoc around it, give it actual documentation, tell people where each one of these is supposed to be used, because everybody loves writing documentation, yeah? So write the documentation. It will save you in the long run. But add the constants, and then add them back into the code, which makes it look a little bit nicer. We've not got those magic strings. Maybe it's just the color that VS Code gives strings in my IDE. I don't know. But I just don't like magic strings. But in that particular example, I've got a class called diagnostic names, which has got a lot of constants on it, or we're pulling in that file. OK, the other thing we've got is enriching the current context with things like the query string parameters. Because in the Express instrumentation, it will put in the query string. What I will tell you is, probably from the next release of the Express instrumentation, all of the URLs will be redacted. All the query string parameters will be redacted. So you won't get them even in the URL path attribute by default. If you want a rant about why that happened, come see me afterwards. It's not a good one. But what you should be doing is thinking about which ones of those attributes on your query strings and in the objects that have been posted, which ones are important. Take them out, give them a name, put them on your span. A couple of other concepts within tracing. We've got span events. Span events are a point-in-time action within a span. They're an extra blob of data that you can attach to a span that says this happened at this time inside of that span. Provide additional context, things like exceptions. But they're essentially attached to the span, which means that if we do sampling, then it will be sampled with that particular span. If we decide to discard that span, they'll be discarded as well. They're basically like a log, a very structured log, very intentional log. But they're basically like logs, but they come in the format of the signal of tracing data. which means that when we do, when you get to scale and you have to do sampling, we'll sample out all of those things. If we do it with logs, they're a different signal, they won't be sampled together. So where you can and you have that need for writing a log line, use a span event instead. They have some properties, not really important. Things like this. Span events are really cool when we do stuff like validation events. And we'll go, we validated something and it failed. You might not want to fail the span. The span might not have failed. But you said, yep, at this point in this span, we did this thing and it failed. And they're really easy, just add event on the span. Nothing more complicated than that. If you've got exceptions in your code, I mean, nobody in here writes code that throws exceptions because, you know, we all write non-buggy code, right? But if you do, and you put a try-catch around it, catch the exception, record the exception. Now, you'll notice that there's 2 lines at the bottom of that, record exception and set status. Because record exception does not mark the span as failed. In a scenario where you've got retries, for instance, you might get an exception on the first one, retry it, and it works fine on the second one. The span didn't fail, but you did record an exception against that span. So, apologies, that slide. So you'll notice at the bottom there, the 2 methods. We're setting error on this one because we're saying that, nope, we haven't done anything. This one is actually going to error on that particular thing. Now, the other one is span links. Span links are an alternative to showing a parent and child relationship. They're an alternative to doing that big waterfall thing. Because they're casual rather than causal. I had to read that like 20 times to make sure I got the 2 the right way around. I'm fairly certain they're the right way around because there's very little difference between the 2. But they're not a dependency. They're really useful in distributed event-driven systems where things can happen days or weeks afterwards, where what you actually don't want is a trace that's this wide. That might not be the right idea. So you might want to say, yeah, I'm going to say this is an action, but in my other action, it's a brand new trace. Maybe it's sending an email that we sent maybe a day afterwards. But I do want to be able to get back to the original thing that caused this to happen. And if we do that, we use a span link instead. So the new one becomes its own trace, and we link it back to the previous trace. So it transitions the trace context, essentially, the trace, individual trace, and allows us to put 2 of them together, which makes it an alternative to the parent and child relationship. It's not as useful if you're using event-driven systems and things like that. There's entire talks on when to use that. I've got some YouTube videos coming up on that as well. So, naming. It's hard. One of the 2 big problems in computer science, which are naming, cache invalidation, and off-by-1 errors. I love that joke. Nobody laughs, but I love it. I laughed. So what should you do? Now, we have something called the semantic conventions in OpenTelemetry. These are conventions that the OpenTelemetry community have painstakingly sat in meetings on Zoom for days and days agonizing over each individual name and why it should be like that. And then Elasticsearch comes along and says, we've got all these new names. Do you want these ones? But we've got these standardized names. So request.body.length. http.request.body.length, I think it is. Or body_length. I don't know. They're standardized attributes. They have names. It solves all of those debates that you have when somebody goes, yeah, but we should call it this. And it's like, yeah, but we should call it this. This one's way better. And then you spend 6 months of any project deciding on naming. And then your runway runs out and your company folds. Use the semantic conventions where they exist. If it's a standard concept that you're doing, chances are there is a semantic convention for it. Go and have a look at the docs. If you're using your own names, your own spans, give them some name spacing. So put your name at the bottom of them, an abbreviation of your company name at the bottom. There is no mandated number of depth of how far you go with this. Just make them descriptive. Put them in those constants files. Give them documents. If you really want to, try and use shared packages. If you've got concepts in your organization that transition an individual team, throw those constants in an NPM package that everybody else can use. So everybody starts using those constants across teams. That consistency is important. Use more properties, not objects. Don't serialize things into your attributes. Use properties, use intentionality. The thing that everybody loves, document it all. Document all your properties, document all your extension methods, all your abstract class methods that you've added to abstract that context away. Document why they're supposed to be there, when people are supposed to use them. And the other one is don't use dynamic property names. Use explicit property names. Because otherwise you're not going to be able to analyze, use analytics and graph these things, because they're all going to have different names. Who here has not heard of Aspire? I think there's 5 talks on Aspire here today. So Aspire, you've probably seen screenshots like this. I think this is actually from like preview 6. But similar sort of idea. It is an OTLP dashboard. It is OTLP native. All of those things that we've just talked about, they can go into this dashboard just by saying, run the dashboard. You don't need to use a full Aspire app. Run the dashboard via Docker and send all of your signals that you've just done in your JavaScript app straight to that. It is the best thing you can use for local debugging because it brings all those signals together. It is really easy. It's really, if you want to talk about how you get people to care about telemetry in your organization, show them Aspire. Show them some of that auto-instrumentation and show them it in Aspire. Use that for debugging. Your local stuff. Doesn't have to be for production. But yeah, it takes all of the signals. So the final thing is sampling, which I saved for the last part of the last session of the last day because it's the easy thing. It's only maths. It's only like, high-level maths and sampling characteristics and all that kind of stuff. It's really easy, honest. So sampling is how we reduce the amount of data in a tracing context. It's how we reduce the amount of data without removing the context. We have 2 methods. We can do it in the head or in the tail. You can do it in the middle if you want. I'd like to call that torso sampling. But ultimately, the most common ones are head sampling and tail sampling. It allows us to retain the context of a full trace, so we can see the whole trace or none of the trace. What it does is reduce the amount of storage. It reduces ingest volumes. By reducing both of those 2, you can increase the performance of your queries because we've got fewer amounts of data points to be able to query. And we do that by retaining context about the wider system. So if we say we're going to take 1 in 10 of our traces for this particular route and 1 in 100 for this particular route, at scale you can get statistical significance of those things by segregating by characteristics. It's the reason why we can do, say, exit polls for elections. We can do all of these kind of, where we take a massive sum of data, boil it down to one small thing, and get really accurate data. With telemetry, you've got to accept data loss. You're never going to get 100% fidelity of that data. Don't use it for profit and loss analysis. That's what your database is for, your data warehouse, your data lake, your data swamp, whatever you want to call it. But it allows us to be able to see approximations, and we use sampling for that. If we do head sampling, what we're doing is we're performing the activity before that thing has been created. So before the web request has been fulfilled, before the if it's a blob storage and we're throwing a file in blob storage and that was the activity that's just created this span, we do it before we create the span. And what that means is we can remove all the process overhead of creating any spans throughout our entire system for that action, which makes it really, really useful. But the problem is it has limited access to information. It knows things like the user agent because we've got the web request. So it knows the user agent. It knows the the URL, it knows the endpoint, the protocol, it knows all of those things. Doesn't know whether it's going to error. Because at the point when you create the request, if you knew it was going to error, I'd probably fix that bug first. Because if you know it's going to error, then just make it not error. But we don't know whether it's going to error at that point. And that's the only place we can make a decision in head sampling. Now, what I would say is most organizations use a combination of head sampling and tail sampling when they hit scale. But tail sampling, it runs on a delay after the initial span, the root span. When that comes into our centralized location, like an OpenTelemetry collector, it runs on a delay after that. We give it about 5 seconds sometimes to say, let's let all the other spans from all of these other services, because things happen. There's an eventual consistency approach to getting all of the spans from a trace into one central location, because we've got batch windows to contest with, that kind of stuff. So we give it a bit of delay. We run it as part of the collector. The advantage is it has all the spans, all the data on all the spans across the entire trace. So we've got the root span, we've got all of the HTTP calls that we've made, we've got all the database calls that have been made that we can use to make a decision as to whether we're going to keep the whole trace or whether we're going to discard that trace. It does delay sending spans to your backend. That is a trade-off. And if you're already on a backend that's got a 5-minute SLA, an extra 30 seconds is not going to matter. If you're on a backend where you're seconds to be able to query that data, 30 seconds can feel like an eternity when the system's down. So do bear that in mind. And it also requires the application to send all of the spans to that individual collector infrastructure. And what that means is if you're on a cloud platform that treats cross-availability zone traffic as a revenue stream, AWS, then that can be quite expensive. Azure has recently just announced that they are not charging for cross-AZ traffic, which, yeah, it makes it really nice. But it sends them all to that location. It will then make a decision as to whether it's going to keep it or it's going to discard it. You send that over to your backend, and the good backends are the ones that are able to keep that. If you've ever used Custo in log analytics for Azure, then you'll notice that there is an item count and an item. So you never count the number of items, you sum the item count, and that's because sampling is taking place. Sample is generally taking place in most of the big backends that you don't see. It's already happening. But if you feel like you're getting there and there's a lot of stuff, then absolutely look at sampling. It is an entire 2-hour, well, we've got a 2-day workshop on just sampling. So, you know, there is a lot to look at, but just know that it exists and it's a mechanism to reduce that cost without reducing the fidelity of the data that you've got. Very quickly, what's coming up? We've got more semantic conventions that we're signing off. Currently, the HTTP spec has been signed off. We've got database and messaging are the next two that are coming up. So there'll be more standardized names, which means more packages that will be out of the RC stage, the release candidate stage. More and more of that is happening. We've got more libraries, so more of the tools that you use every day, more of the libraries that you use, we'll be getting more instrumentation packages. Now that we're going to V1 on most of the things, everybody's getting on board with it now, so there's more libraries every single day, and all those libraries are getting more robust. They're getting faster. Some of them did have performance issues. All of that stuff is happening. Better documentation, that's my job. I love writing documentation, honest. But I work on trying to improve the OpenTelemetry documentation, which comes on to my last point, which is we need to know what you want. We need to know why you're not using OpenTelemetry right now if you're not using it. If you are using it, what are your pain points? What are the things you're struggling with? More importantly, what are the things that the rest of your teams and colleagues are struggling with that you think are easy that we can help with in the OpenTelemetry community to make it better? So you get the talk. I get all of that from you. So feel free to come down and have a chat with me. There are stickers. I would be remiss if I didn't say that Honeycomb offer a free account. We do take all of those 3 signals as well and have a unique approach for you to be able to analyze that data. You can sign up without a credit card. You can get started today. We also literally wrote the book on observability engineering, or I didn't. My CTO and some others wrote it. It's free to download. Go find it. Other than that, I don't think we've got time for questions here, but feel free to come down and have a chat. I'm here for the rest of the day.